Okay, so welcome to Chapter 12, Section 2, Forces of Attraction. We're going to be looking at two types of attraction with molecules. One is between the molecules, that is intermolecular. The other is within the molecule itself, and that is an intramolecular attraction. A couple things before we get started. I am going to be going rather quickly, and that is because I only have 15 minutes. The other thing is, you'll notice there's going to be a big webcam image of me here, which I know you are thrilled to death with, and you may minimize that and pick it up and move it around so it's out of the way if you need to. Okay, now why are we studying these forces of attraction? Because these forces of attraction, both the inter and more importantly the intramolecular types of attraction, really determine if something is going to be a solid, a liquid, or a gas at different temperatures. In other words, these forces can determine the boiling point. The stronger the forces of attraction, the stronger or the higher the boiling point. Now, we're going to do a quick review here of our intramolecular forces of attraction. And we did not call them intramolecular forces of attraction at the time. At the time, we called them bonds. And we studied three bonds, as you can see here: ionic, covalent, and metallic. These are the most effective forces of attraction. These primarily determine whether it's something that is a solid, a liquid, or a gas at different temperatures. And the strongest type of bond, remember, was the ionic, and ionic bonds are formed between metals and nonmetals. Okay, between cations and anions. And so generally ionic compounds have a high boiling point because it's a very strong type of bond. And then we have covalent bonds, which are formed between nonmetals, and this is where electrons are shared, whereas in on ionic bonds the electrons are transferred, if you remember. Okay, and then the third type of bond was a metallic bond that's formed between metal atoms, where their valence electrons all kind of mesh together and allow them to be good conductors, allow them to be malleable. Okay, but don't forget, bonds are the strongest type of molecular attraction. So that's a quick review. Now we're going to go on to the intermolecular type of attraction. Now, when I say intermolecular, I'm talking about the attraction between molecules, not within the molecules, but between them. So I'll draw a little diagram for you here. I'm going to put a molecule that has two atoms in it, a yellow and a green atom. And then I'm going to just show you that these molecules are going to be attracted to each other. And that is called intermolecular. We're not talking about the bonds. We're not talking about the bonds there. We're talking about this intermolecular attraction. These are weaker than the intramolecular types of attraction. And there are three of these types of attraction. The first one is called a dispersion force. Okay? And again, it's intermolecular attraction. It is the weakest type of attraction, intermolecular attraction, and it is in all molecules, although it is the only type in nonpolar molecules. Nonpolar molecules won't have any other type of intermolecular attraction except for dispersion forces. Sometimes they're called London dispersion forces after a gentleman, I think his first name was Charles London. The other thing is about dispersion forces, they will get stronger as the mass of the molecule increases. So if I had H2 here and N2, and I said which will have the strongest dispersion forces, then you would look at the mass. You'd say, well, H2 is 2 grams, N2 is 28 grams, so nitrogen would have the greater dispersion forces because of its mass. Okay? So what does this mean? Well, let's look at a question here. which of these molecules here would have dispersion forces? Well, that's a rather easy question because I just told you that all molecules have dispersion forces. So the answer is all of them. Now, the second question is a little bit different, though. It says which would only have dispersion forces. And to answer this, then you've got to go through and figure out which of these is a polar molecule and which is a nonpolar molecule. Well, helium is just an atom, so obviously there's no positive and negative charge to that. This is a diatomic. They're the same on both ends, so that's nonpolar. That's diatomic. That's nonpolar. And then we're going to look at NH3. Well, if you remember, NH3 had a trigonal shape, and I'm sure you remember that. And so this ends up having a negative end and a positive end. So this is a polar molecule, which means then that it will not have dispersion forces. It will not have dispersion. So we said this would be all, this would be only the nonpolar molecule. We were getting through those. We just said that NH3 is polar, so that is not going to have them. So we can eliminate that. We know this will have it, this will have it, this will have it because they're nonpolar. Well, what about carbon dioxide? Well, if you remember and you do the Lewis dot structure, you see that carbon dioxide has two negative ends and a positive end. And so this actually, even though you might think it's a polar molecule because it has 3 atoms, is nonpolar. So that also will have dispersion forces. And then I hope most of you realize water is a very polar molecule, that it's a bent shape and you have a positive and a negative end, so that will not have dispersion forces. Now the last question was which would have the strongest dispersion forces. Then let's look at these 4 that have dispersion forces and look at their mass. That's 2 grams, this is 28 grams, 14 times 2. Iodine is like 254 grams. I think iodine is 127, and carbon dioxide is 44 grams. So which would have the strongest dispersion forces? The one with the highest mass, so that would be iodine. Okay. Now, the second type of intermolecular attraction is the dipole-dipole force, and this is formed between polar molecules. When you have a polar molecule, you get the dipole-dipole forces of attraction. The pole refers to the positive or negative end of a molecule. So if you had something like HCl, this end would be positive, this end would be negative. And so then if you had another HCl nearby, it's going to be attracted here to the positive end of, or the hydrogen end, and the chloride end, the negative end, would be attracted to the hydrogen end of another nearby HCl molecule. Okay, so that's all that the dipole-dipole is. It's if you have a polar molecule, the positive and negative ends of the nearby molecules are attracted to each other, and that is what a dipole force is. So let's look at this. Which would have dipole forces? Well, to answer this question, you have to say, well, only polar molecules are going to have dipole forces. So helium is nonpolar, nitrogen is nonpolar, iodine is nonpolar. We saw carbon dioxide was nonpolar. And then we did say, yep, ammonia was polar, nitrogen was sticking above the hydrogen, and oxygen was very polar. So those two would have dipole forces of attraction. Now this next question is a little tricky. Which would only have dipole forces? Well, when we talked about dispersion forces, we said that dispersion forces are in all molecules. So the answer to this is none. They would all have dispersion forces as well as dipole forces. They would have both dispersion and dipole. They would all have both of these forces of attraction. Now, the third type of intermolecular attraction, and this is the strongest type of intermolecular attraction, is the hydrogen bonds. And even though it's called a bond, it is a type of intermolecular attraction. It's just that it is so strong that we call it a bond. It's so strong, we call it a bond. Okay, so this is the strongest type of attraction, the strongest type of intermolecular attraction. All right, so it's a special type of dipole attraction. It's a very, very strong dipole attraction. Okay, and it only occurs between molecules that have hydrogen and oxygen, hydrogen and nitrogen, and hydrogen and fluorine. And that's because the electronegativity difference between these atoms is so great that when we have these molecules next to each other, they will actually form a weak bond between the molecules. So we say it's a weak hydrogen bond because as far as bonds go, it's very weak. But as far as intermolecular attraction, as far as the intermolecular attraction, it is the strongest type. And it's a special case of a dipole. Okay. So if you have this, if you have hydrogen bonds form between your molecules, then you're going to have a very high boiling point, abnormally high for its mass. So that's what we're talking about here. Here with this is a water molecule, this is my oxygen, and these are my hydrogen ends. And so the attraction between the oxygen and the hydrogen of the nearby water molecule, this is so strong that this forms your weak hydrogen bond, which is a strong, strong, strong type of molecular attraction. It not only gives water a high boiling point for the mass of it, it also gives it other problems like a high cohesion, high specific heat, high heat of vaporization. It's the reason why water is less dense as a solid. Ice floats, and that's very unusual for solids to be less dense. Well, let's put all this together in the next minute and see if we can arrange these molecules according to their boiling point, based on whether they have only dispersion forces, if they have dipole and dispersion forces, if they have hydrogen bonds. All right, now this one, we all know right away that they all are going to have dispersion forces. So I'm going to put dispersion by all of them. They will all have dispersion forces. And the more mass, the bigger the dispersion force. Okay. Now, if they're diatomic, then that's the only force that they will have. So this is diatomic, 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 diatomic. Those are the only they're nonpolar molecules. All of these are nonpolar. So that's the only type of molecular attraction that they're going to have. Okay. Now this nitrogen and oxygen will also have dipole. So I'll put Di for dipole. This is a polar molecule, so it'll also have dipole. And this is a polar molecule, so it also will have dipole. This, now remember, carbon dioxide, it's a non-polar molecule, so it's only going to have dispersion forces. Now, of our dipoles, which would have hydrogen bonds? Well, remember, we said hydrogen bonds can form between hydrogen and oxygen, so this would have H bonds, hydrogen and nitrogen, and hydrogen and fluorine. So these two would have H bonds too. These are going to have our highest boiling points. Okay, so now we have to look at how we would order them within each category. So let's look at all of the ones that just have dispersion forces. And we know that the lightest one will have the lowest boiling point. Since this is 2 grams, we're going to say that'll be the lowest boiling point. Oxygen, O2, would be 32, nitrogen would be 28, fluorine would be 71, and this would be 44 grams. So let's order these now according to their mass. So we would say nitrogen would have the second highest boiling.